Alright, so in this video we're introducing some chord, secant, and tangent theorems. Now, theorems is just a fancy math word for a rule that's always true. It's been proven to be true all the time. If you don't understand what the chord, secant, and tangent are, I suggest you hit pause right now, go back and rewatch those videos that I just did about the definitions, or ask some questions in class, okay? Because you got to know those definitions to be able to use these rules. Otherwise, you're just going to be lost. And I don't want that to happen. Alright, so the point at which a tangent line intersects a circle is called the point of tangency. If a line is tangent to its circle, then it's always going to be perpendicular to the radius of the circle at the point of tangency. So in this picture, in circle Q, the line L is tangent to the circle at point P. So point P is called a point of tangency, and based on this rule that's always true, since the line L is perpendicular to the radius of circle Q at the point of tangency. So anytime you have a line that's tangent to a circle, it's always going to be perpendicular to the radius of the circle. So keep that in mind. Now we're going to apply that rule to an example. In example 18, you're standing at point C, which is 8 feet away from the outside of a grain silo. If you don't know what a grain silo is, right around in the country, that's the big circular buildings that hold grain. The distance from you to a point of tangency, that's a key word, okay? I see a math word, I need to underline it. On the tank is 16 feet. I want to know what the radius of the silo is. Okay, so again, let's talk about point of tangency. We know, we just had a rule, anytime we have a point of tangency, it's perpendicular to the radius. So since we're told that point B is a point of tangency, we know we have 90 degrees right here. Well, as soon as I have 90 degrees, look what kind of triangle I have in my picture. I have a right triangle, and as soon as I have a right triangle, the very first thing that should pop in your head is something that you've been doing for years now called the Pythagorean theorem. And that's a squared plus b squared equals c squared. Here, c squared is always your hypotenuse, and the hypotenuse is always directly across from your 90-degree marker. So my c squared, so my c is going to be r plus 8. And it doesn't really matter what a and b are. I'm going to call this side a, this side b. I'm looking at the sides of my triangle. So a is going to be 16, b is going to be r. And I'm just going to plug into my Pythagorean theorem now. So when I do that, I have r squared plus 16 squared plus, I have more than one thing, so we got to put in the parentheses, something that should be an equal sign here, equals r plus 8 quantity squared. Now, we could solve this by hand or we could graph it. I'm going to do it by hand. First thing we need to do is figure out what 16 squared is. I believe it's 256, but let's double check. Maybe I'm right, maybe I'm not. So 256, good. All right, so r squared plus 256 equals, now r plus 8 quantity squared. I need to do some scratch work, and I'm going to do that over here on the side. What r plus 8 squared is, that's the same thing as saying r plus 8 times r plus 8. Hopefully you already knew that. If you didn't, don't tell me, because you should be embarrassed. But as soon as you know it's r plus 8 times r plus 8, you can use FOIL or the box. I want to use the box to multiply that out. So r times r is r squared. R times 8 is 8r. R times 8 is 8r. And then 8 times 8 is 64. So when I combine my like terms for my scratch work, I have r squared plus 16r plus 64. So that's this side now, r squared plus 16r plus 64. Now, I have a quadratic, and in the last chapter we talked about solving quadratics, so I need to get everything on the same side. So I'm just going to say minus r squared minus r squared. Cancel out, cancel out. So 256 is equal to 16r plus 64. Well, that was convenient. This is a lot easier now. So I'm going to subtract 64 because I want to get r by itself. So 16R is equal to 256 minus 64. Let's use calculator there. I think it's going to be 186. We'll see if I'm right. 192. So it's close, only 6 off. But good thing I used my calculator. I didn't let my pride and my ego get in the way. Alright, so 192 divided by 16 is going to give me my radius. So R equals 192 divided by 16. Let's use calculator there. So that's 12. And that's what I was asking for. I wanted to know the radius of this ring side line. So that means I have 12 here, I have 12 here. So, fill in the picture. What is the radius of the solid? 12 feet. You answer the question. And we did it by starting off with the fact that point B was tangent to the circle. And since it was tangent to the circle, that means it was perpendicular to the radius of the side line. If we didn't know that, we couldn't do anything. So it's very important you understand these rules. Okay? Another rule. If two segments from the same exterior point are both tangent to the same circle, then they're congruent to one another. Let's talk about what this means. I have two segments that are... It's a really long bell. Anyways, I have two segments, 1 and 2, that come from the same exterior point. So my exterior point is X. And they're both tangent to the same circle because they touch the circle, each touch the circle in exactly one spot. Well, if that's true, then these two segments, segment RS, is congruent to segment TS. So if you want to write it out in words, RS is congruent to TS. What that means is essentially these two segments are the same size, same shape, and most importantly, the same length. Okay? So let's use this fact and do an example. In example line 19, we're told that line AB is tangent to circle C at point B. Also, line AD is tangent to circle C at point D. We want to know the value of X. Well, let's look at this. First off, these two segments are coming from the same exterior point, and they're both tangent to the same circle. Well, we just had a rule about that said if it comes from the same exterior point and it's tangent to the same circle, then these two segments must be congruent. So what that means is AB is congruent to AD. And these little slashes are just what math people use to say that segments are congruent. Since they're congruent, that means they're the same length. The symbol that means the same is equal. So now I can make an equation. So I have 11 equals x squared plus 2. Now I just want to get x squared by itself. It's my first objective, so I'm going to subtract 2. Okay, so I have x squared is equal to 9. And I want to get x by itself now, so I'm going to take square root. But square and square root cancel out, that's no problem. But since power is even, I need to consider plus or minus. So I have x is equal to plus or minus square root of 9. But the square root of 9 is just 3. So x equals plus or minus 3. Well, I could write it like this or split it up. So x equals 3 or x equals negative 3. But let's think about what we got, or the context of what we have. If I plug in, you might think, well, this is a distance, so you should only talk about positive numbers, but not so. Because negative 3 squared is 9, 9 plus 2 is 11, so it works. Positive 3 squared is 9, plus 2 is 11, so it works. So we want to keep both values, so x equals 3 and x equals negative 3. Okay? Again, when you have two tangents that come from the same external point and they're tangent to the same circle, then the segments that they form are always congruent, always the same. So it lets you very easily create an equation. And then you just solve like we do just normal algebra. And that's it for this video. Be sure you know these rules. They're going to come up again, I promise. If you need help, please ask questions. Please let me know. I want to help you.